welcome. Now we're going to solve for some missing variables, and this is a parallelogram. So we know the features of a parallelogram will hold, and we'll write down what feature that is just to help review the features of a parallelogram, and these are in your notes. All right, so we want to find x. Right, so here's where the an expression with an x is. Right, and we know that the opposite sides of a parallelogram are congruent. We're going to abbreviate parallelogram, so we don't have to keep writing it. We're just going to write p-gram. All right, so p-gram means parallelogram. Are congruent. So that means that 5x equals 27 and x equals 27/5 is a fine answer. This is a terminating decimal, so if you want to change that to a decimal, that's okay. If it's not a terminating decimal, just keep it as a fraction. But this would be 5.4. So either is okay with me. Right, now let's solve for y. All right, so here we know that the diagonals bisect each other, so that means those parts of the diagonal are congruent. So it means that 2y minus 5 equals y plus 4. Let's get all the y's on one side and the variables on the other. So let's subtract y from both sides. And remember, you would do the opposite because the y's are on different sides. Right? So if I want to get rid of the y on the right-hand side, I have to subtract y from both sides. So 2y minus y is y, so we have y minus 5 equals 4. Now we want to get y by itself, so we'll add 5 to both sides, and y equals 9, right? And that would be the answer there. And then last of all, z. So let's see where z is located. So z is right here, right? And it's just that part of the angle because it didn't tell us it's the whole angle, right? So it's just that part. We know that on z here, that opposite sides of a parallelogram, and we'll just abbreviate that p-gram, are parallel. So therefore, and I'll just write therefore this time, therefore the alternate interior angles are congruent. All right, so that means that 3z is equal to 33. I'm going to put a little line there so it looks like a z and not a 2, because 32 equals 33 would be very strange statement to make. So I'm going to make sure that looks like a z. So now we'll just divide both sides by 3, and we'll solve for z. Z is 11. So these were actually really easy to solve. You just had to know the property of parallelograms that applies. And there are some problems like this in the homework. They are mostly on the second page, 12 through 20. Now some of them aren't parallelograms, some of them are other type, well, they're parallelograms, but there are special types of parallelograms, and you'll learn how to solve for those in the next series of lessons. But some of them are parallelograms, and you can actually solve those. All right, so now we have 3 more parallelograms. Right, we'll write down the property so that we remember it, and then we'll solve. In the first one, the property that we're going to use here to solve for x and y are that opposite sides of a parallelogram, I'll just put p-gram again, are congruent. Now that means that 3x is equal to 6 and y minus 1 is equal to x plus 2. Now you don't want to start off with y minus 1 equals x plus 2 because then you have 2 variables. Let's figure out what x is by using 3x equals 6. All we have to do is divide both sides, divide both sides by 3, and I guess I was thinking of the answer there, and we get x equals 2. Now we can solve for y. We can set up the equation x plus 2 equals y minus 1 because we already know what x is, so we can do a replacement. You can't solve with two variables, but if you know what one of those variables is, you can replace it. So that would be 2 plus 2 equals y minus 1. So 4 equals y minus 1, and to solve for y, just add 1 to both sides. 5 is y. All right, so now we found out what x is. We found out what y is. Let's solve for x and y in the next question. All right, so x and y within a single question, if there's more than one x, they have to have the same value. But once we move to a new problem, the x's and y's don't have to have anything in common. This is a new problem. Right? And so the feature of parallelograms we're using to solve question number 13 is the fact that opposite angles of and I'll put p gram for parallelogram, are congruent. So that means that this angle, 2x, is equal to 70, and it means that x plus 3y equals 3x plus 5. Boy, that's not writing very nicely. Now, let's not start with the one that has x's and y's in it, right? Let's solve with the one for the, let's solve the equation with just one variable in it, right? Because that's a lot easier. And then when we know what x is, we can find y. So let's start with 2x equals 70. All right, well, that's really easy to solve because all we have to do is divide by 2, and then x is 35. Now we can solve the harder question, which was 3x plus 5. By the way, you can drop those parentheses. That's just telling you the whole measurements in degrees. So 3x plus 5 equals x plus 3y. All right, now we couldn't solve this if we had two variables normally, but we already know what x is. So we can replace both of those x's with the 35. So then we have 3 times 35 plus 5 equals 35 plus 3y. All right, so now we can multiply the 3 times 35. So we're going to simplify that whole left-hand side there. So 3 times 35 is 105 plus 5 equals 35 plus 3y. 105 plus 5 is 120. So 120 equals 35 plus 3y. We want to get y by itself, so let's subtract 35 from both sides. Right, so that's going to be 85 equals 3y, and then just divide both sides by 3. That does go in evenly. How you can tell is if you add up the digits of a number and they add up to a number that's divisible by 3, then the number is divisible by 3. It's just like a threes trick. So, excuse me, it's 85, not 84. 85 is not divisible by 3. 84 is, because 8 plus 4 would be 12. 85, that would be 13. So I don't know, I had number, I guess I wanted it to be divisible by 3, but no, alas. So we'll leave it as y equals 85 thirds. Let me just make sure that there's no addition errors. Sometimes we don't always get fractions in there. So sometimes when you see it, it's not a bad idea to go back and check. Well, the x equals 35 is correct because 70 divided by 2 is 35. And then 3 times 35. The equation there, yeah, I didn't miss anything there. So that's going to be 90 plus 15. Yeah, that's 105. That's 120. That's all correct. I didn't write down anything wrong. Right? 35 plus 3y is good. Subtract 35 from both sides. Yep, this all looks good. It's just 85 thirds. That's okay. Right, let's solve the last one. Right, and the property we're using here is that diagonals of a parallelogram bisect one another. So that means that 3x is equal to 12 and x plus y is equal to 5y. Again, let's start with the one that only has one variable. So 3x equals 12, divide both sides by 3, and x is 4. And then x plus y equals 5y. We know what x is, so we can substitute a 4 there. So 4 plus y equals 5y. We want to get the y's together, so let's just subtract y from both sides. 4 equals 4y, and then divide by 4. 1 is equal to y. So we solved for x and y in all of the questions. I'm just going to box them there. All right, so that's all of these. There's only one thing left in your notes. It's completely filled in, but I just wanted to go over it with you. All right, so that's the last problem we have, solving for missing measurements in a parallelogram. These are like ones in your homework. And this is the last thing in your notes, and it's already there. I just wrote it in as opposed to it being typed like in your notes, but it's the same information. So one last way to prove a quadrilateral is a parallelogram. This one just doesn't come up as much. All right, so here I have the same parallelogram ABCD. And in this parallelogram, triangle ACD is congruent to triangle CAB, and triangle DAB is congruent to triangle BCD. So if a quadrilateral is a parallelogram, each diagonal, so it does take both of them, not just one, each diagonal divides the quadrilateral into two congruent triangles, right? So that is another way, right? So, and actually this is it actually would only take one of them, right? Because we'd have corresponding parts of congruent triangles congruent, and we could prove that the figure is a parallelogram. So it only takes one to prove it, but it's true that it's true for both. So in other words, if I draw in a diagonal, if I know something is a parallelogram already and I draw in a diagonal, then those triangles created by either diagonal will be congruent. But it actually only takes one set of congruent triangles to prove the the quadrilateral is a parallelogram. Right? It's just not used as much, but I thought I would introduce that one to you as one last way. All right, well, that's the end of just plain old parallelograms. In the next series of lessons, we'll look at special parallelograms. Thanks for watching. Bye for now.